Hi, I'm Brian Prier, tutoring high school physics. Today's topic, lenses. So there are two major kinds of lenses, converging and diverging, and we're going to do a lot of the same things we did with lenses as we did with our concave and convex mirrors. So we're going to start with an object and we're going to form an image. The big difference between lenses and mirrors, though, is that lenses allow light to pass through the lens as opposed to reflecting them like a mirror does. So let's start creating some images with these two lenses. So as always, there are going to be three rules. First off, you need two rays to form an image. Second, a ray that goes parallel to the axis will be reflected through the focal point. And finally, a ray that goes straight through the center will keep going unimpeded. So let me show that to you on a converging lens. We have a ray, it goes straight parallel, and then it's sent through the focal point. Another ray that goes through the center, and they intersect right here. And so I created our rays at the head of this object, so this will be the head of an image formed here, and there you have it. So on to the diverging lens. The big difference between the diverging and the converging lens is that we consider the focal point of the diverging lens to be on the same side as the object. What does this mean for our image? Well, let me show you. So as always, we have our parallel ray, and now it needs to be sent through the focal point. The trouble is that the focal point is here, but light rays pass through a lens. So here's what we do. We take a line that goes from the focal point upwards, and so we'll get an actual ray of light heading out this way, and we're going to extend it backwards to go through the focal point. This isn't actually where the light is coming from, but we perceive it as so we extend it backwards. And so we also have the ray of light that goes straight to the center, unimpeded, and they intersect here, creating a very small image. Okay, so are these images real or virtual? Well, the rule differs in terms of lenses as opposed to mirrors. So here it is. If the image is formed on the same side as the object, it's virtual. So over here we have a virtual image. If it's formed on the other side as the object, it's considered real. So this is a real image. So let's get down to the numbers. Where are the positives and negatives? Well, the distance that the object is always going to be considered positive. However, for everything other than the object, if it's on the same side as the object, it's going to be considered negative. So this focal point, it's not the object, but it's on the same side as the object, so this is going to have a negative distance, a negative focal point, if it's a diverging lens. However, if it's on the other side of the lens from the object, then it's going to be considered positive. So this is a positive focal point. You'll notice that we have the exact same equations for lenses as we did for mirrors. So we're only going to work through this one time. And so let's say we want to find the image where we have a diverging lens, focal point of negative 20 meters, because it's on the same side as the object, and mounted distance of 4 meters. So where's our image? Well, 1 over our image distance, unknown, plus 1 over our object distance of 4 meters is equivalent to negative 1 over 20 meters. So now we subtract 4 meters from both sides. 1 over di is equivalent to negative 5 over 20, which just becomes negative 1 over 4. And so we have our image distance of negative 4 meters. Negative 4, since it's negative, that means it's going to be on the same side as our object. Now, a bit of a shortcut when working with the numbers here. If you end up with a negative image distance, then it's going to be virtual. If you end up with a positive image distance, it's going to be real. To finish off, let's find the magnification of this. So magnification is equivalent to negative distance of the image, negative 4 meters, over distance of the object, 4 meters. So we simplify that, the negatives cancel out, and we just have 1. So the image is going to be the same size as the object. If it were negative, it would also be upside down. And that's pretty much it. To recap, there are two major types of lenses, converging and diverging. As before, we'll have a focal point, and we're going to use some rays to find out where an image is created. We need at least two to form an image. A ray that goes parallel to the axis and then strikes the lens will be sent through the focal point. A ray that goes straight to the center of the lens for either lens will simply keep going straight through. When working with a diverging lens, the ray of light will have to pass through the lens, so extend it backwards through the focal point to create that particular intersection. Note that this is not actual light, but the light that we perceive. If the image appears on the same side as the object, it's a virtual image. If it appears on the other side as the object, it's considered a real image. When working with numbers, anything that is not the object, but is on the same side as the object, is considered to have a negative distance. Anything on the other side of the object is considered to have a positive distance. The object itself will always have a positive distance. Use the exact same equations as we did for mirrors. 1 over the distance of the image plus 1 over distance of the object is equal to 1 over the focal point, and the magnification is equal to negative distance of the image divided by distance of the object. Alright, that's all for now. Again, I'm Brian Prier. See you next time.